Hey everybody, welcome to the video solutions for quiz 7. This is problem 1, where we are given an infinite series and asked to use the geometric series to compute the value of this infinite series. So we better recall what the geometric series tells us. So let's see. If you have a series which starts at 0 and goes to infinity, and you have some ratio r which you're raising to n, the nth power, well, there's two cases. So if the absolute value of r is less than 1, then the series is going to converge. And not only is it going to converge, but it'll converge to 1 over 1 minus r. On the other hand, if the absolute value of r is at least 1, then this series will diverge. Okay, so how do we use the geometric series here, right? We're supposed to have this ratio r raised to a single power n, and over here, well, there are powers, that's good, but they're raised to different numbers. Okay, well, we're not that far off, right? Like 4 to the n plus 1, we could think of that as 4 to the n times 4 to the 1. And then this 4 to the 1, I could just pull out of the sum. So I say, okay, this is 1 over 4 times a sum from 2 to infinity. And now what am I left with? Negative 3 to the n over 4 to the n. Oh, but I could just write that as negative 3 over 4 raised to the n. And now it looks exactly like my geometric series. Oh, I said exactly, didn't I? But it's not really exactly because I still have this 2 and that 0. How are we going to handle that? Okay. You know what? Why don't we just prove a better version of the geometric series test here, right? Now, the proof of this, of course, I'm not expecting during, a quiz that you're going to just come up with this proof, except you can do it in this situation. So let me show you what I mean. So let's say we were starting not at n equals 0, but some other value k. So what do we do in this case? Well, what we're going to do is do a little reindexing. I want to start it at 0. And the problem is this. If I write to the n here, this is just demonstrably false, right? Unless k is equal to 0, one of these has more terms in it at the beginning. Okay, the issue here is that at the very first spot, my n equals k, so my first term should look like r to the k. And over here, it looks like r to the 0. But I can fix that. I can fix that by writing a plus k up here. And if I do that now, okay, when n is 0, I get 0 plus k, which is k. That's what I'm supposed to start with. And as n goes up by 1 over here, n will go up by 1 over here, and these will actually be the same thing. However, I can now rewrite this as r to the n times r to the k. And because this r to the k has no n involved in it, as far as that series is concerned, it's a constant. I can just pull it right out the front. So this is equal to r to the k times, well, now we're right back into the geometric series that we started with. So I can rewrite this now as r to the k times 1 over 1 minus r, provided, of course, that the absolute value of r is less than 1. Obviously, if the absolute value of r is greater than or equal to 1, we'll still be in the divergence case. Okay, so I can combine this, and I get r to the k over 1 minus r. Okay, so this tells us that if you start not at 0, but at k, with the sum of the geometric series, r to the n, you're still going to be dividing by 1 minus r, but then you're going to be multiplying on top by r to the k. So actually, right, that's pretty neat, right? We could do the same reasoning right here. We could just use the formula, in fact, but let's just use the same reasoning. Put this into practice, and we say, okay, we want to start at 0 instead of 2, so we'll start at 0. But because we were supposed to start when n is 2, I will add 2. Okay, if I do this, then I can break this up as negative 3/4 times to the n, excuse me, times negative 3/4 squared. This negative 3/4 squared will just come right out the front. And I'll have a fourth times, well, let's see, negative 3/4 squared is 9/16. And then I'll have this sum from 0 to infinity, negative 3/4 to the n. And now I can use the geometric series test. Because the absolute value of negative 3/4 is less than 1, this will be 1 over 4 times 9/16 times 1 over 1 minus 3/4. Okay, we could do a little more work here if we wanted to do some arithmetic. Let's see, 1 minus, oh, we made a mistake now, didn't we? Because this wasn't 1 minus r, this is actually 1 minus negative r, right? We have a negative 3/4 here. So our r is negative 3/4. This should be a plus. Oh, wow, we almost biffed that one. All right, so this is actually 7/4 on the bottom. 1 over it will be 4/7. Okay, so this piece here is 4 over 7. Hey, the 4 and the 4 will cancel, and we'll end up with 9 over 16 times 7, or I guess, let's see, that's 112 on the bottom. All right, whew, almost messed that one up, didn't we? All right, so that's how we can use the geometric series test. If you want to see a different approach, here we go. I really like the approach I just gave you, but there is another way we could have done this. So remember, we've gotten down to 1/4. N goes from 2 to infinity, and then we have negative 3/4 to the n. So what we could alternatively have done is said, well, what if instead of starting from 2, we started from 0? But we just kept this the same. In this case, we are adding too many things. Right? We're starting at 0 instead of at 2. So if you add too much, well, you better get rid of it. So let's subtract, okay, first the n equals 0, and then the n equals 1 case. Those are the extra cases we just put in. So when n equals 0, we get negative 3/4 to the 0. And when n equals 1, we get negative 3/4 to the 1. Okay, so if we handle it this way, all right, this first piece, well, it's exactly what we had up above. This is a geometric series. This is 1 over 1 minus, negative 3/4. Then we have minus, well, negative 3/4 to the 0 is 1, minus negative 3/4 is plus 3/4. All right, and we already know this piece is going to be 4/7. So when you multiply it by 1/4, you'll get 1/7. And then what do we have over here? We have minus 1 plus 3/4, so that'll be minus a fourth, but times a fourth out here, so minus 1/16, which again is going to be 9 over 7 times 16 is 112. Okay, so we have a couple different ways we can approach it, but man, this first method, right, that's pretty neat that we can write down the more general formula. So I like that one too.